So I'm going to show you how to make the NRF24 today. This is my design. What we'll need is the NRF24 module. I like to use this one, the EO1 by eBite. I feel like it's a bit better quality than the other ones you can get. You can get these ones here as well. I've used these before in the past. Just the quality is not as good as the other one, so I'm going to go and use this one here. So that's just a bit of a size comparison. This one's a little bit longer, and this one's obviously a little bit wider. So it'll be similar to what we did for the CC1101. Pretty much the same principle, just different footprint, just because it's a little bit wider, about the same length. Actually, it's a little bit longer. First thing we want to do is we want to remove the plastic from the actual board. So we just use some tweezers or some small screwdrivers to gently pry it off, just so we've got the actual module by itself with no plastic. Then we want to get the breadboard. Because I've done this last week with the CC1101, I've still got a little bit of leftover board. So we've used less than half on the other modules, so you should have enough left if you're following along and making them to use the leftover to make this module. Essentially what we want to do is just place it onto the prototype board, and this will give us a template to what we need to cut. So as you can see, essentially we need to cut that row and then row A as well. So you just want to trim it just to make sure it's the right size. Test fit it again, and that's pretty much the size we sort of need, rough size, and then the rest we're just going to sand off. So I'll do a bit of sanding and it'll be fast forwarded again. So I've just sanded it. Essentially you just want to sand the top and bottom sides just to the end of the letters, or the top of the letters, and the sides pretty much all the way to the edge of the circles on both sides. And that should give you a pretty good good fit and should match the actual module board as well. So next we just want to solder the header pins onto it. So essentially we're going to put it here. So we need 8 pins. So 1, 2, 3, 4, 5, 6, 7, 8. Let's give it a snap. They give you the pins. I like to use something to actually put the header pins in first, and it helps for the soldering process. So this is exactly what I did for the other module. And just another thing I like to do is when I put the actual pins in, you can actually give it a little bit more of a press down. So I don't know if you can see it, it's just gone slightly further in. So this will just help give it a little bit more depth and engagement when you put it into the flipper. So, and it means you also need less trimming. Just give it a push down. And just make sure it's all level. And this one will be going in third, so 3 up. So 1, 2, 3, and then the spacing of 1. So if we go like that, so it should look like that. And then we can just solder it in. It should look like that once you're done. Next, we just want to remove the pins from the 3.3 watt converter. So remove the plastic. And just make sure that this side doesn't have any solder poking out. Just want it flush with the board. And then we just want to super glue it onto the board. With just a little bit of super glue. Now we can just run the wires for the positive and negative. Let's get a bit of wire. So the wiring is going to be exactly the same as the CC1101 module. It's essentially just a different footprint. So everything else is pretty much exactly the same. Same process, just different footprint. So we want to put the voltage into the board. Just carefully solder that. And that's going to go to pin 1 over here. Now do the negative to the 3.3 volt converter. Let's trim that a bit. and then we want to put that to pin 8. So 1, 2, 3, 4, 5, 6, 7, 8, which is the negative. We don't want to cut this wire, we just want to just strip it in the middle. Like that. And then we just want to wire in the voltage out. Okay. Then we just want to add 5 extra wires in. So we just want to put some wires to 1, 2, 3, 4, 5. So I always prefer to have a bit more wire than too short. So you can always, the rest will just be waste anyway, but that's fine. You just don't want it to have too short because it makes the process a little bit more difficult if it's very short. So I'll just tin the ends as well. Give them a nice trim. You don't need too much. So essentially you should have pin 1 going to the voltage into the 3.3 volt converter, and then you have additional 5 wires, 1, 2, 3, 4, 5, which we'll wire in now. So essentially what we're doing is we're going to put the wires into the corresponding holes in the actual prototype board of where it corresponds to the module. So when we look at the pins on the module, it's 1, 2, 3, 4, 5, 6, 7, 8. And on the board, pretty much where it's going to sit is here, is pin 1, 2, 3, 4, 5, 6, 7, and 8. So this is exactly the same pin out of the CC1101 module as well. So for pin 1, it's the negative. So we'll get the negative wire. And this one's actually a bit easier than the other module because we've got a lot more space to play with. Essentially, run the wire up to the hole and just give it a trim or strip it as close to the hole as possible. And just thread it through, and yeah. Pin 2 is the positive, so we'll get the positive. Same thing, strip the wire as close to the hole as possible. Pin 3 corresponds to pin 6 of the GPIO pins for the flipper. So if we go to pin 6, it goes 1, 2, 3, 4, 5, 6. So it's this one. Pin 4 of the module goes to pin 4 of the flipper, so 1, 2, 3, 4. Pin 5 of the module goes to pin 5 of the flipper. 1, 2, 3, 4, 5. pin 6 goes to pin 2 of the flipper, so 1, 2. And pin 7 goes to pin 3 of the flipper. So 1, 2, 3. And it should look something like that. The next thing we want to do is just the same thing we did last week as well, and just solder on some spacers. So the spacers just got the front. It's going to look like that, and then exactly the same thing as we did last week as well, is we just want to sandwich the wires in between. So we've got to line up the pins to the holes, and just make sure the wires go in with it as well. And you'll see the wires are still pushing through, so that's good. And then we can just squeeze it all the way. And we just want to put the spacers at the back as well, so it's an even front to back. So do one side first, solder it in, and then we can move to the other side. And we just want to make sure all the wires are pulled through. And nothing's shorting in between. So if we pull it through, it'll help pull the wire through so it's close to the hole as possible. And there's nothing touching there, no shorts. So we're good to solder. Just want to clamp it in. If you want a really clean look to the board as well, you can cut these flush first, but you just got to make sure all the wires are pulled through. So only do a couple at a time. So just cut this one, and I'll cut it flush. I'll cut this one flush too. This will just give it a slightly cleaner look, but if you're not comfortable doing it, I would just recommend just soldering it with the pins high, and then you can trim it a bit later. So it gives it a nice, clean, soldered look as well, instead of being a bit more rough. Then we can just put another spacer on the other side. This is a temporary spacer. And we'll do the same thing, so we'll clamp it in. Just make sure the wires are pulled out. So you can solder it like this, as is, or do what I'm doing and just cut it flush. And then we can just do the in-between ones now. Okay, so we're done with the soldering part now. And what we just want to do now is just glue the front section in because we haven't put glue in, so it's a bit loose. Just a little bit of glue. You might want to just make sure it's lined up a bit. So the module's lined up. So it's a bit. So the module's lined up with the prototype board. And there you have it. That's pretty much the board done. And this next step is just adding that an LED if you want the indicator. So we just want to trim pin 1 and pin 2. Just so it's a little bit more flush. So you just make sure the green indicator side is on pin 1 for the negative. And try to carefully get clamped on. Just wait for the soldering iron to heat up. And there you go, should be ready to use. So this is what you'll end up with, something like that. And we'll just test it out to make sure it's working. So put an antenna on it. So you don't usually want to run any of the modules at all without an antenna. Apparently you can get damaged the actual module. We want to go to the GPIO settings, make sure the 5 volts is on, and the LED indicator's turned on. So that's running up to 3.3 volts now. And just want to go to your sniffer or mouse jack app. Let's go to sniffer. Change that to, I think 4,000 is a good sample rate, and you'll just see it flicking through the channels and just scanning it, see if you can find anything. So hopefully you found this video helpful, and if you want to see more content like this, please like and subscribe. I'll put a link up to the 3D cases on printables, just like the CC1101. Enjoy.